Hi guys, and welcome to this important uh, uh, section in which we're discussing angles on the Cartesian plane. And this is, of course, in terms of the trig ratios. I'm going to label this point here R, um, which will have the coordinate X and Y. Okay, so that's one. And I hope you remember previously from the unit circle, the introduction, we said that is 90, we said this is 180, and we said this down here is 270, and that is 360. Very, very important to note. So the Cartesian plane is divided into 4 quadrants. Quadrant 1, we can see we have here values of x that are between, let me not use x, let me rather say theta as an angle, because I've already used x there. So we have theta, which is between 0 degrees to 90 degrees, okay? And maybe I should also use a inequality form, so to just introduce you to that, so that you are not, you are very familiar with. So I'll do that between that. So that is where we have got theta, and maybe the inclusion case might just be too much at this point. Let me not do that. Let me use strictly less than and do that. Here we've got a theta between 90 and 180, and this is quadrant number 2. Here we have got theta between 180 and 270, okay, degrees, and this is quadrant, of course, number 3. And then finally here we have got theta between, of course, 270 and 360 degrees. Whether you include or not, it doesn't really matter. I just prefer to use open intervals at this point. Okay, now the next thing that I need you guys to understand, we are going to figure out all the trig ratios, in particular the signs, whether they're positive or not in each quadrant. Now, if I've got x squared plus y squared, then obviously this thing here is r, is the hypotenuse. And one thing that I want you to establish is that the hypotenuse is always positive in either quadrant. So in quadrant 1, quadrant 2, quadrant 3, and 4, the hypotenuse will always be positive. Here is my angle theta. Notice I started by drawing the hypotenuse, and to construct my right angle, I go down to the x-axis and not the y-axis. And that's how our triangles are going to be formed. So coming this side, here is my R, and my triangle, I'm gonna go down to the x-axis. Let me call this point P, and here, what is this side here? Remember, to the left side, we know the Cartesian plane, x is negative, y remains positive there. We'll do the same thing down here. We draw the triangle towards the x-axis, and this remains my R. Let me call this point Q, okay? And here, x is negative and y is also negative. Finally, I'm gonna draw my last triangle there towards the x-axis. Let me call this one S. Here, x is positive and y is negative. You know this is the negative y-axis, that's the positive y-axis, positive x-axis, negative x-axis. So now, having said that, I said we are going to find out what the trig ratios are, what the signs of the trig ratios are in particular. If I look for sine theta here, You agree with me? It is what? Opposite y over r, which is hypotenuse. So I just want to put here minus y, and that r minus y minus x here, and positive y, so that you can follow closely. Right, so easily rather. So now sine theta is what? Opposite, which is y, over hypotenuse, which is r. So the sign is positive. You will realize that is the same thing with cos, which is x over r. Same thing with tan. What is tan? Opposite over adjacent, also positive. Interestingly, the reciprocals are also positive. I have already spoken about this in the previous video when I was talking about notations and the common temptations there. The reciprocal of sine, I have also already indicated, is the cosecant. And I said if sine is opposite over hypotenuse, it will be the opposite, which is r over y. The same thing here with cosine. The secant is the reciprocal, sec theta. And if cos is x over r, then sec will be r over x. For the tan is the cotangent. If tan is y over x, then cot will be x over y. And you can see they are all positive. In other words, all the ratios are positive. Whatever ratio you're going to figure out here, whatever side, whether this over that or that over that or that over that and that over that, you will always have them as positive. Things start to be interesting in the second quadrant. What we have now here is that the sine of theta, maybe because I'm in the second quadrant, I should pick a different color. Now, the sine of angle theta here is opposite. So I'm going to use this theta here, a reference angle, y over what? R, which is positive. The cosine of theta adjacent, notice it is minus x over hypotenuse, which is r. The result is negative. The tangent of theta is opposite y over hypotenuse minus x. And you can see, you know that positive divided by negative is negative. The result is negative. Coming to the reciprocals, watch this with me. Cosec is r over y. So I'm just going to swap those two. So that means cosec theta is also positive. Sec theta is r over x. So here in this case, r will come down, r will go up, x will go down. We see that basically the sec theta is negative. The same thing with the cotangent. If the tangent is negative, this will also be negative. So something very interesting is that only sine, okay, only sine and its reciprocal cosec are actually positive in this quadrant. Here they are all positive. Here only sine and its reciprocal are positive. You will do the same thing for the rest. It is not surprising. You see here that sine theta, okay, and there is my theta. Sine theta is what? Opposite here is minus y, and there is r. We see sine is negative. Cos theta, adjacent, there is minus x, hypotenuse is positive, we see the result is negative. Tan theta, we also see the same now here, is opposite, which is minus y, adjacent is minus x, then it's positive. As we did with the reciprocals, the same will apply. So cosec in this quadrant is negative, cosec will be negative in this quadrant because sine is negative also. So cosec of theta will be negative. Here, sec of theta, the ratio will be negative. The cotangent will be positive since the tangent is positive. And finally, the last quadrant, if that is my theta there, then we have the following. Sine theta, here's theta, opposite is minus y, hypotenuse is r, so we see sine is negative. Cosine of theta is adjacent, which is x, the hypotenuse is r, that is positive. Tan of theta, we can see the opposite is minus y, here it is, and the hypotenuse is what? Sorry, I think I'm getting a little bit tired here. The tan is opposite over adjacent, which is that, and this is negative. My apologies on cos. This should have actually been an r and not a y. See, I think I've spoken a lot, so now I'm starting to make mistakes. All right, so obviously the same applies for the reciprocals. That means here cosec theta is negative, here sec theta is positive, and finally cot theta is also negative. So what do we have? What have we established here? We have established that in the first quadrant, the ratios are all positive. In the second quadrant, only sine and its reciprocal is positive. In the third quadrant, only the tangent and its reciprocal, which is the cotangent, are positive. And finally, in the fourth quadrant, only the cosine and its reciprocal, the secant, are positive. There is a nice acronym for this that is being used. You might have heard it. They call it the cast rule, but meaning they are going the other way. But I like having this acronym that says all students take care. Okay, all students take care, meaning all the trig ratios are positive, only sine and its reciprocal, only tan and its reciprocal, and only cosine and its reciprocal therein. This was a long one. I'll pause here. In the next video, we will now take up some nice examples that come with restrictions, and we will be using the Cartesian plane to solve that. Cheers.